Hi guys, today we're looking at trigonometry, and specifically we're looking at defining the trigonometry ratios. So we're looking at the right angle triangle. So this is our first example. Suppose we have this triangle here. Okay. Let's look at this triangle here. This is our triangle. So suppose we have A, B, and C, right? So we're saying this is our angle A, angle B, angle C, and angle A is 90 because we're looking at right angle triangle. So let's try to draw it here and see. Okay, let's try to draw it here and see. Okay, so this is our 90 degree. This is A, this is B, and this is C. So we call these angles. So it's a angle A, angle B, and angle C. Okay, so when we're looking at angle B, and then let's say we have our angle B as beta, for example. So if we're looking at angle B, or we're looking at the angle beta, so if you're looking at this side of AC, we can call it B. AC is the same as B, and we have BC, and BC we can call it A, and we have AB, and we can call it small letter C. Okay, so if you're looking at angle B or at our beta, this will be an opposite. This side here is opposite, and then this one here we call it an adjacent. We call this one an adjacent side, and we call this one an hypotenuse. We're calling this one an hypotenuse. We're saying this is an hypotenuse. So we're looking at it as we are in angle B or angle beta. So this is our opposite side, and this is our adjacent side, and then this will be our hypotenuse side. So we're looking at these three sides. Okay, and then from trigonometry we can also introduce the ratios. So we have normally ratios are sine, so it can be sine beta or cos beta, or we can have tan beta. Okay, so as we're still using this example here, and then we can say our sine beta is equal to, sine beta will be equal to A all over, B all over A, of which is the same as our opposite all over hypotenuse. That would be our sine beta. So we can also look at cos beta. Our cos beta will be C all over A. This is the same as, so our cos beta would be the same as adjacent. It's an adjacent over hypotenuse, right? And also when you're looking at our tan beta would be equal to, B over C, and this is the same as tan beta is the same as opposite all over adjacent all over adjacent. So when you're looking at beta or this angle B here, so if you're looking at side, you're looking at the opposite side all over our hypotenuse, so that is side. But if you're looking at cos, your cos, if you are at this angle B, your cos will be C all over A, of which is an adjacent all over hypotenuse. But if you're looking at tan, then our tan will be an opposite all over adjacent, only if we're looking at the angle of beta, right? Okay, suppose we have an angle like this now. So suppose we have an angle like this, and then let's say the same angle, we can still call this beta, and we can say we have 9, so we can say this is B, this is A, just as the same as the above one, right? And then suppose this is theta, let's say this is angle theta. So when we're looking at sine, let's say we're looking at sine theta, now it means we're looking at it from this side of angle theta or angle C. So you see what will happen now when we're looking at sine theta. Sine theta should be nothing, because you remember this is a C and this is B and this is A. So if we're looking at sine theta, and then we are looking at this angle theta here, so sine theta should be C all over A. You see, this is the same as opposite all over hypotenuse, but we say opposite when we're looking at the angle from angle theta. So you see, it's not the same. It depends on which angle are you coming from, because you see, when we're looking at this angle beta, then we're saying that sine is B all over A. But when we're looking at sine from this angle theta, then we're saying it's an opposite, and in this case opposite is C and the hypotenuse is A. So it depending on which angle are you coming from. And same thing apply. Let's say we were looking at cos theta, and cos theta will be nothing, because at cos theta, so this is our theta, we're looking at it from this side here, so our theta, and then we're looking at cos. So you see, our adjacent side will be this B here, so we will have B all over A, because this will always be our hypotenuse. Normally the hypotenuse side would be always the longest size of it if you're looking at the length of it. I think this can help you to understand a little bit of trigonometry as well. Thank you so much for watching.